That's good. Right, guys, could you please comment your names? And we're going to start today looking at summation signs, like we started last time. So I'll make these a bit bigger. There we go. So can you guys start with those two? I'll start Teams chat as well. Make sure your names are commented. And then we'll get started with these. So yeah, if every one of you could, because they both show that, so I'd like a picture of your workings, please. Cool, just joining that Teams chat now. Cool, all right. And register. So we've got Elliot's, we've got Harry. Jay's here, just not. Yeah, fine, no worries, Jay. As long as you're watching on YouTube, that's fine. Harry, Lucy, Jay, George, Scott, Chloe, Tristan, Danny, Louis, Guy, Ollie, and Billy. Cool, so I'm missing Nula, who said she was going to be away today. She's going to watch it later. Jake, anyone heard from Jake at all? And anyone heard from Callum and Becky? Cool, we'll see what's happening with those guys later. Cool. Yeah, if you guys are, that's fine. As long as you can send your answers, that's all that's really needed. Okay, so I'll give you another couple minutes to work your way through this one. I think 4 minutes sounds fair to me. So 4 minutes starting from now. See if you can answer these two and send me your workings. Alright guys, don't forget to comment your answers. I give you a bit extra time there, but I haven't had any responses. Are people stuck? If you're stuck, ask for help, but please don't just sit there, because that defeats the point of lessons. So I'll start going through it, but please ask for help and please comment in the future. Lucy, thank you very much. That was just come through. Alright, so like I said last time, we need to put in the R values we've been given into the R equation and sum it all together. So for the first one, sum R equals 1 to n, 2r. We need to put in every value from 1 to n. So we're going to kind of start this. So the first value we put in will be 1. So we're going to get 2 lots of 1, which is 2. Then we're going to put in R equals 2. 2 times 2 is 4. Next one, put in 3. 2 times 3 is 6. Keep going, and the last value we get is 2n. So it wants me to find the sum of this. Now, looking at this one, it's clearly an arithmetic series. So we could use the arithmetic series equation to find the sum, which is n over 2. 2 lots of the first value, 2 lots of 2 is 4. 2a plus n minus 1, and the difference is also 2. So if I expand all this, we're going to get n over 2, 4 plus 2n minus 2. And if I expand that, we're going to get 4 take 2 is 2. So we're going to get one more step of working. Let's scribble out the first line, the second line. So we'll get n over 2, 2 plus 2n. Expand that, we end up with n plus n squared. So that's the first one done. So it's the same idea. Put the values in, see if it's a series that you know, use the equation if you can. Alright, second one, this looks a little bit trickier. So first term, we're going to again expand it. So we're going to we did the first one. So the whole first bit, well, skipping a bit here, that is the same bit in this in the last question. So I'm just going to say the first bit is n plus n squared. Cool. Then we need to take away this other bit. So I'm going to start working out all this sum. So let's do all this in red and in some brackets. So the first term here is going to be 2. Take 1, which is 1. The next term, put 2 in. 2 times 2 is 4. Take 1 is 3. Put the next one in. Oh my god, everything's pinging. Next one in, 3 is 3 times 2 is 6. Take 1 is 5, so plus 5. And this is going to keep going on until we get to 2 times n is 2n. Take 1 is 2n. Take 1. That's our last term. Alright, so again we can use the sum equation on this series. So we get n over 2. 2 lots of the first term, so that's 2 times 1, which is 2, plus n minus 1 times the difference, times n minus 1 times the difference, which again is 2. So we'll work all this bit out. We're going to get n over 2, 2 plus 2n, take 2. If I get rid of the stuff at the top, do my next step because I run out of space. So we're going to get n over 2, 2 take 2 disappears, so we get n over 2 times 2n, which is 2n, which is just n squared. So the whole of that bottom bracket just becomes n squared. And then we can see we've got n plus n squared, take n squared, which simplifies down to n. So that's the proof for that one. Right, has anyone got any questions? I had Harry and Lucy reply. Let's have a quick look. Jay, just say didn't understand it. All you got to do, Jay, is put terms in, see what it is. If it's a series that you know, use the equation, and then lots of simplifying. So I'm just going to have a quick look at what Harry and Lucy said. Lucy, yeah, good. Yeah, brilliant. Both of those. And Harry, yeah, good, fine. So the trick to these is not being afraid to just, you won't spot it straight away. Put values in and then kind of detect what it is. Alright, let's try another one. Cool, a little bit tricky perhaps. This is a 7-mark question. Give you guys 7 minutes to do it. So again, put values in, see if it's a sequence or series that you know, and then go from there. So 7 minutes. If you need any help, guys, please comment. Don't just wait for me to get through it. I'd like to see more of you than to give me your answers. 7 minutes starts now. Right, guys, any ideas? Do you want some more time, or let me know? Anyone stuck? I haven't had any feedback at all. Any ideas? Anybody got any solutions? Anyone stuck? Need any help? I don't want to do all these for you. You won't learn anything. So let's just say you were stuck. What could we do? Right, let's put in r equals 1 into the equation and see what happens. So r equals 1. We'd get 2 times 3 to the power 1, which is 6. Okay, now, alright, let's try r equals 2. So 2 times 3 to the power 2. 3 to the power 2 is 9, so we get 2 times 9, which is 18. Let's go again. R equals 3. 2 times 3 cubed. 3 cubed is 27. 27 times 2 is going to be 54. Right, is that a series? Well, let's have a look. Does 54 divided by 18 equals 3? 18 divided by 6 equals 3. So every time we are timesing by 3. Cool. So really, we've got a geometric series here. It's just kind of hidden. So hopefully that's enough hints for you guys. I'll give you 3 more minutes to try and solve this one. But if you're ever stuck, just find the first few terms, see if it's a series or a sequence that you recognize. So 3 minutes starting now. Alright, so we got Louis, Lucy, and Chloe. Okay, well, I'll finish going through it and then I'll have a look at your answers in a second. So, found the first three terms, and we've discovered it's a geometric sequence starting with 6 with a ratio of k. And it wants us to try and find what the value of k is. Well, k is n in this equation because we're going up to k terms. So a is 6, r is 3, and we want to find k. We know the sum is 59,046. So we're going to say that is equal to the sum equation, 6, 1 minus k to the power 3, 1 minus r to the power k, and r is 3, 1 minus 3 to the power k, divided by 1 minus r, which is 1 minus 3. So that's just using my equation, Sn equals a, 1 minus r to the n, 1 minus r. Yep. Okay, so working this out, 1 minus 3 is minus 2. And we got a 6 there as well, so if I times both sides by minus 2, so 59046 times by minus 2 minus 118092 equals 6, lots of 1 minus 3 to the power k. Divide by that by 6, get minus 19682 equals 1 minus 3 to the power k. I can then rearrange some things, so I can add the 3k to the left hand side and add the 19682 to the other side to get 19683. Oops, that should be 3 to the power k, not 3k there. I'm then going to log both sides. So log 3 to the k is log 19683. Bring the k down the front, so k log 3 is log 19683. Divide by log 3. And that should give me my answer. Which gives me k equals 9. So, oh, didn't even need to do that. Whatever. So, for part B, we probably need to know that k is 9. So, for this value k equals 9. Calculate the sum here. This one's going to be a bit tricky. We've not done one like this before. So basically, it wants me to work out the sum from r equals k plus 1. So k plus 1 is going to be 10 to 13 of 2 times 3 to the r. Now, the way we can do this is, because we want to sum from 10 to 13, we can't just say n is 3 and do that bit. We've got to work out all of 13, all of 10, and then subtract them. So we need to do the sum from 1 to 13, take away the sum from 1 to 10. Actually, we don't want to take away 10. Sum from 1 to 9. And then we'll be left with the sum of 10 to 13. Does that make sense to everybody? That's where it gets a little bit tricky. Okay, so I'm going to work out my geometric sum. We still know the first term is 6. Alternatively, you could find the 10th term and go from 10th to 13th. It's a bit more tricky to think about that way. I think this way is the easy way to do it. So you're going to go from 1 to 13. So that's going to be 6, 1 minus 3 to the power 9. Sorry. What am I talking about? 1 minus 3 to the power 13 over 1 minus 3. Take away the sum from 1 to 9, so that's going to be 6. 1 minus 3 to the power 9 over 1 minus 3. So I can type all this in at once and it should just spit out the answer. So 6, 1 minus 3 to the power 13 over minus 2. Take away 6, 1 minus 3 to the power 9 over minus 2. And that gives me 4, 7, 2, 3, 9, 2, 0. Why is it 9, not 10? If you take away 10, then you won't be including the 10th term. So basically, we want to find the 10th plus 11th plus 12th plus 13th. So we don't want to include, we don't want to take away the 10th value. We want to have that one. So we want to do like, does that make sense? If I write it all out, I'll just answer Louis' question there a bit clearer. So imagine one of them is 1 plus 2 plus 3 plus 4, skip a few, plus 9 plus 10 plus 12 plus 13. The other one, we want to get rid of everything that isn't from 10 to 13. So we want to take away all this bit here. So we're going to take away 9 plus 8 plus 7, blah, 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 2 plus 1. We want to take away all that bit. So that's why I'm only doing the sum from 1 to 9, because I want to get rid of that term. Does that make sense to you? All right, let's have a quick look through your answers then. So, Lucy, yours is quite a lot bigger. I think you've done the sum from 1 to 13. But remember, we only want to go from 10 to 13, so you need to do a subtraction there. Louis, you had the right idea, but you used 10, so you were pretty close with your answer. But that's the question I've hopefully just cleared up there. And Chloe, you've done 13 as well, but you haven't taken away the bottom because we don't want to go from 1 to 13. We wanted to go from 10 to 13. Does that make sense to everybody? Still only 3 of you answering, so I'd like to hear from all of you. Otherwise, I'm going to have to start removing attendance because you guys technically not here. Ask for help if you're stuck though. Right, next one. So we've got a geometric series here. Series is convergent. Write down the range of possible values for x when the sum to infinity is 2, and then calculate the value of x. Cool. So remember the sum to infinity, a over 1 minus r. See how you guys come with this one. It's 6 marks. I think I'm going to give you 8 minutes though because it is a bit trickier. Comment if you need any help. Right, we got one answer so far from Harry. I'll give you guys 2 more minutes, but I do want to get on with this. So 2 minutes to get your answers in. Please send me, even if you haven't finished it, send me what you got so far. 2 minutes. Okay, so first bit's tricky, but we've got to break down. They haven't given us much information, so we need to break down exactly what they've said. They've given us a series 1 plus 3x plus 9x squared. They've said it's convergent. Write down the range of possible values of x. Well, there's not a lot to go on apart from the fact the series is convergent. So series is convergent means that first of all the sum is going to go to one kind of number. It's going to get closer to it. Also means each time the terms are getting smaller. So if each time the terms are getting smaller, it must mean that 3x is smaller than 1. If we divide by 3, we get x must be less than 1/3, which gives me a possible range of values for x. Because otherwise, it doesn't converge. That makes sense for everybody? We could also have a look at the second term as well, or the third term. So we could say 9x squared is less than 3x. So 9x squared take 3x is less than 0. We can factorize that and say 3x squared, 3x take 1 is less than 0. We could sketch that quadratic, which crosses at 0, third. We could say either x must be between 0 and 1/3. Does that make sense? There's a lower range on this as well. Not only is it just less than a third, it also needs to be more than 0. Because if we had a negative value, it wouldn't be converging, it would be diverging. So the full range for this one is given by that, looking at the the third and the second term. Okay. So I think this is a different sum here by the looks of it. We'll see what happens. So we've got another summation sign here. Calculate the value of x. We're told that the sum is 2. The sum to infinity is 2 for this one. So if we work out the first few terms, when r is 1, we just get 1. When r is 2, we get 3x to the power 1. When r is 3, we get 9x squared. So this is the summation that describes the series they gave us at the top. And we're told basically the sum to infinity is 2. So I can go in and say, okay, well, 2 equals the first term, which is 1, divided by 1 minus. What's the common ratio here? Well, each time we're timesing it by 3x. So 1 minus 3x. We want to try and solve this for x, so I'm going to times up my 1 minus 3x to the other side. So we get 2 lots of 1 take 3x equals 1. Expand that. 2 take 6x equals 1. Add the 6x to the right hand side, take the 1 from the left hand side. 2 take 1 equals 6x. So 1 equals 6x. So x equals 1/6. Cool. Alright, let's see what you guys said in terms of answers then. Billy, close. Your part A answer is not quite right though, so I think you needed to sketch it. Harry, we got an answer from you. Your part A was alright. I don't know why you got R was -1 or 1 there. But yeah, part B was good. So is part A kind of straightened out for everybody? I think a few of you are a bit confused about it. Does that make sense though? So solve the inequality using the third term and the second term. Right, what's next? Okay, that's kind of the end for summation. There will be some on the assignment, so let me know if you guys still need any help. I can always get more questions if you need it. But the last bit of the sequences and series topic is what's called the recurrence relationship. Now, recurrence relationship is an equation that what's the word I'm looking for? Creates. Yeah, I guess creates is fine. Creates a sequence. Right, equation that creates a sequence. So, as an easy example, this could be the first one. So we have un plus 1 equals un plus 2. So this is an example of a recurrence relationship. And they might tell us u1 equals 3. So what this tells me is the first term is 3. So let's write our terms at the bottom. What's my second term? Well, if I want to find my second term, this is like the developing sequence, so I'm glitching a bit. Could you guys tell me if anyone else is experiencing that? If not, Billy, just try and rewind and watch it slower. So the first term is 3. If I want to get the second term, we can look at this bit. So this tells me un plus 1 is un. So imagine un is your first term, n is 1. Your next term would be n plus 1. So this will be the term after n. Does that make sense? This is the first term. This is the term after, because it's 1 more than n. So whatever term this is the next term. It looks alright on my preview, so I think it might be your internet, guys, but I'll keep going. If you need to rewind it, just rewind it. So if I want to generate the second term, I use the first term plus 2. So second term is the first term plus 2. So my second term is going to be 5. If I want to generate the next term, which will be my third term is my second term plus 2. So my next term is going to be 7. So that's a recurrence relationship. It's a relationship between a term and the term before it. It tells you how to generate the next term. Right, we're going to try another one of these. So un plus 1 is 2un minus 3, and u1 is 5. Could you guys find me the second term, the third term, and the fourth term? So I'll give you 2 minutes to have a think about that. So find me the next 3 terms in the sequence. Right, any ideas? So this tells me the next term is 2 times the current term, take away 3. So if I want the second term, I'm going to do 2 lots of the first term, take away 3. So 2 lots of 5 is 10, take 3 gives me 7. If I want the third term, it's going to be 2 lots of the second term, take 3. So 2 lots of the second term is 14, take 3 is 11. If I want the fourth term, it's 2 lots of the third term, so 22, take 3, which is 19. Nice. Elliot, Billy, brilliant. Well done. Alright, let's try a slightly harder one. Un plus 1 is un squared minus 1. Could you guys find u2, u3, and u4? So again, 2 minutes to try and find these ones. I've just lost the YouTube stream. Where's it gone? There, let's go. All right, you've all gone for 3, 8, 63. Hopefully that's right. Let's have a look. So 2 squared is 4, take 1 is 3. Good. 3 squared is 9, take 1 is 8. 8 squared is 64, take 1 is 63. Yeah, spot on. Good. All right, let's try one that's even harder. And could you guys find U3, U4, and U5 this time? So I'll give you a little bit longer because it's a little bit trickier. So 3 minutes this time to try and figure out what's going on with this one. Cool. 2 comments so far. Billy, you've made a mistake there, I think. So first term, we bit harder this time. Let's go through this in a bit more detail. So this tells me that if this is our first term, this must be our second term, and this will generate our third term. Or in other words, you could say A term 2 in the future is a term 1 in the future minus the current term. Yeah, so n is the smallest number here, so this is got to be the first term, next term, term after it. If this was the 5th term, this will be the 6th term, this will be the 7th term. So to find our 3rd term, we're going to put the 2nd term squared, so it's going to be 3 squared, take away the 1st term, which is 2. So we get 9 take 2, which is 7. So yeah, Billy, you got that bit right. 4th term, we need to put the 3rd term squared, so that's going to be the one we just got, so it's going to be 7 squared. Take away the 2nd term, which is 3, so 7 squared is 49. Take away 3 is 46. And this is where it gets massive. Now we have to square 46. So we have to do 46 squared, take away the 3rd term, take away 7. 46 squared gives us a massive number. Let's work it out. 2116. Take 7, which is 2109. Cool. Right, let's try some actual questions then. Has anyone got any questions about this, or are you all okay with it? Because this is quite hard at first normally. It's just spotting. UN is obviously the first term in a sequence, or if you like, the lowest term you've got. This is the term after it, and this is the term after that. So lowest term, 1 after, 2 after. Alright, let's try another one. So, I'd like you guys to try this. How many marks is this one? Doesn't say. How long have we got? Give you guys 5 minutes to try and answer this one. So 5 minutes starting Right, so I've had one one response from Louis. Thank you, Louis. Right, let's get through this. So I'd like to get one more done. So here's our recurrence relation. First term is 3. Find expression in terms of k. So u2 is k times u1, which is k times 3, plus 2. So u2 is 3k plus 2. So not much else we can do with that. Find an expression for u3. Okay, so we're going to put u2 back into the equation. So u3 is 3k plus 2 times by k plus 2, and we can expand all that. u3 is going to be 3k squared plus 2k plus 2. Alright. Next bit. We're told that u3, that term we just found, is equal to 42. So we're going to say 42 equals 3k squared plus 2k plus 2. And now we're going to solve it. So take 42 from each side. 3k squared plus 2k minus 40. Yeah. Equals 0. It's quadratic, so there's going to be two values, but if we look up to the top, I'm just told k is a constant. Yeah, so there's two values to find. Get my calculator out, go to the quadratic solver. 3k squared, 2k minus 40, which gives us k equals 10 over 3 or minus 4. So those are my two solutions there. Louis, well done, and Lucy, well done as well. I think you guys are the only ones to comment. And Guy, well done as well. Good job, you three. Alright, hopefully we've got time for one more. I did have a few more I wanted to do, but we'll come to those on Monday. So if you guys try this one, we'll try and blast through this in 4 minutes on timer. Do this, we'll go through it, hopefully we'll get that last one done as well. Cool. Has anyone replied? No. Right, let's get done though, because I want to get through these. If you are having any difficulty with these today, please rewatch it and then email me if there are any you're still a bit iffy about. There's loads more in the textbook, so make sure you're using that as well. So we're told the first term and we're told the recurrence relationship. It wants us to find the third term. So we'll start with finding the second term. So second term is the first term times by p minus 3 lots of the first term. So in other words, the second term is 2 lots of p take 6, or we can say the second term is 2p take, oh, not 16, take 12. Okay, third term then, x3, is the second term, 2p take 12, times by p take 3 lots, 2p take 12. So there's a lot of stuff there to expand. I'll get rid of this second term now. So we'll expand the second bracket first. So we've got 2p take 12 still there. Now that's going to be times by p take 3 lots of this bracket. So that's going to be 6p. 3 times 12 is going to be 36. So it's going to be plus 36. So we just need to expand these two now. Oh, we got p take 6p there, so we can make that minus 5p instead. Cool, so timesing these up, we're going to get minus 10p squared plus 60p plus 72p, and then 12 times 36, I think is going to be 432. Simplify that, minus 10p squared plus 132p, take 432. Cool. Right, then we're told that x3, we're told that term is minus 2288. So set it equal to that, find p. So I'm going to solve this quadratic. Take it all to one side, so we're adding 288 to each side. So let's go to my quadratic formula, minus 10, 132. And then I'm going to be lazy and just type in minus 432 plus 288, and it will work it out for me. And we get p equals 12. Or p equals 6 over 5. We're told here though that p is an integer, so that can't be the value, so p must be equal to 12. Hence find the fourth term. Okay, well I know the third term is minus 288, so we're going to start with that one. The equation for the fourth term would be x4 is minus 288 times by p, which is 12, take away 3 lots of minus 288. So we'll work all this out with the calculator. We can basically just type this in if we want. So minus 288 times by 12, take away 3 lots of minus 288. Oh my god, that's a huge number. Minus 252288. So 252,000. Does that seem right? Yeah, it does. Cool. Right, I'm just going to check a few of you sent me solutions. Louis, I don't know if yours. Oh wait, that's the last question. Wait, no. No one sent me any solutions. Okay. Cool. Right, 7 minutes left. We'll try one more of these. So if you guys could try this, 5 minutes. I'll start going through it. We might finish going through it next lecture. So 5 minutes there. Give this one a go. Comment if you need any help as well. Right, I have had one reply from Lucy. Thank you, Lucy. I will race through this just so it's done. So find A3. Right, well we know A1 is K. So A2 is 4K plus 5. So A3 is 4 lots of 4K plus 5, which is going to be 16K plus 25. Okay, show that the sum from 1 to 4 is a multiple of 5. Interesting. Okay, so I need to add all these things together. So I need to find the fourth term as well. So A4 is going to be 4 lots of 16K plus 25 plus 5, which is going to be, get my calculator out, 64K plus 125. So we've got to add K plus 4K plus 5 plus 16K plus 25 plus 64K plus 125. So if I add all that together, we're going to get 16 plus 4 plus 1 plus 64. We get 85K plus 5 plus 25 plus 125, which is 155. And can we take a factor of 5 out of that? Yes, we can. 85 divided by 5 is 17. And 155 divided by 5 is 31. So therefore, factor or multiple of 5. Cool, and that did it. Quarter past, good job. All right, wait, hang on. Mine's different to what Lucy got. Damn it, what have I done? Have I done something wrong or just Lucy? 4K plus 5. 4 times 4 is 16K plus 25. Yeah, you did 4 times 4 is 8. That's wrong. Otherwise, right though, right method. But yeah, you've done 4 times 4 is wrong. Yeah, don't worry about it. Your method is fine. Right, so good. All right, we've got a tiny bit left to do next week, but and then we'll be on to the next topic. Right, make sure you've done the progress check and the assignment for this week. I'll be looking at those over the weekend. And I will see you guys next week. Have a nice weekend. See you on Monday. Cheers. Bye.